Hello, my name is R Campos, and this is my video submission on the poster Relationships between Compressive and Splitting Strengths of Core and Cast Concrete Cylinders. The assessment of a pavement strength capacity is necessary as the pavement ages and sustains the stresses. The present study uses the splitting tensile and compressive strengths of cast and core concrete specimens to develop mathematical regression models that can better correlate the splitting tensile and compressive strengths of high-strength concrete. Testing core cylinders in compression is attractive for QA/QC, quality assurance, and quality control due to the similarities between testing procedures of core and cast cylinder specimens. Furthermore, the tensile strengths of core specimens is estimated in the same way as cast specimens by testing them in splitting tension. The relationship between two types of specimens would be ideal, however, due to factors that decrease the strength of core cylinders, no such relationship exists between the two types of specimens. Instead of relating the two types of specimen, this study aims to combine both core and cast specimen strengths to better predict the compressive or splitting tensile strengths of either core or cast specimens. The nonlinear regression power model is the most common mathematical model used for relating the compressive and splitting strengths of concrete. Because both the compressive and splitting tensile strengths both fail by applying a compressive force to the cylinder, more credence is given to this strength relationship. The relation between the compressive and splitting tensile strengths can be traced back to this nonlinear power regression model. In total, 140 specimens were tested in this study. The average compressive and splitting tensile stresses were then calculated for both core and cast specimens. A comparison can be seen here. The compressive and splitting tensile strengths were related with the power, square root, log linear, and linear regression models. Table 1 shows the root mean square error analysis for equations proposed by researchers, and Table 2 shows the root mean square analysis for the regression equations developed in this study. The complexity of the power model had almost no effect on the root mean square error for each case. It is observed in this figure that the proposed power equation 2 and 5 both trend well with the concrete strengths of cast and core specimens. In this figure, it is observed that the proposed equation 2 trends closer to the splitting tensile strength than the equations used by ACI 363R-10, which is for high-strength concrete. We concluded that the regression equations that only utilize the strength parameters from the cast specimens leads to larger errors when predicting the strengths of core specimens. Both core and cast specimens should be analyzed together to produce the regression equations that can predict either core or cast strengths. Linear and square root models are not adequate for relating the compressive and splitting tensile strengths. The compressive strength has a positive nonlinear correlation with the splitting tensile strength for both core and cast specimens. Finally, I'd like to acknowledge OCAST and Rogue Engineering for the funding for this project.